it's not so many guys in this room, so aren't you interested in native components?
We just left it.
Yeah, that's right. Because a lot of presentation about it and about React and about Angular, so it's not so interesting for me. It's in the past. Okay, so today I'm going to share with you some experience about end user monitoring in single page application. In very huge single page application. Yeah. So a few things I want to say before my presentation. So I saw a lot of conferences and presentation and trainings, and I made some conclusion about after them. And so today you will not see any huge chunk of codes, yeah, thing which you cannot understand, and so on and so on. So I was trying to make my presentation as funny as it possible. Actually, and the last funniest thing, this is the last presentation. After that, we are going to go to make dinner, maybe eat dinner, and so on and so on. So let's start. First of all, I want to introduce myself. My name is Max. Yeah, I'm from Ukraine. Does someone know where is Ukraine? Where is Ukraine?
East of Germany and Poland.
Cool. Yeah, in the middle of the Europe, directly. Okay, cool. So I am in business trip in Utah, and I decided to attend this conference and share our experience. I've been working on one of the biggest companies in Ukraine with name SoftServe. Maybe someone heard about this, but it doesn't matter. For about 4 years. So for Ukraine, it's very long period. So first of all, my experience in IT was database engineer. I was database engineer. But next, actually, I realized that front end is closer for me. So next, after maybe year of database engineering experience, I switched to front end. What else? Also, I like extreme sports very much, and I'm interested in DevOps things, such like, for example, Docker. Yeah, I like AWS and actually all things which you can find in AWS. Also, I like continuous integration and all stuff which is related to it. Yeah, this is except front-end technology, and also cloud computing in common. Okay, actually, why I did decide to create this presentation? Yeah, so the main problem. Let's imagine typical client-server application. Yeah, so time of rendering some page. Yeah, let's imagine that you, for example, you end user. Yeah, and time of rendering some page can be computed from, first of all, time of server-side internal computing. Yeah, so when our servers do some stuff with our request and respond to our response. Second, yeah, it's time of latency. So we will always have some latency because we have internet, a lot of routers, a lot of other things. So this is also we should also add this value. Third, it's browser directly on low level in V8, so we cannot handle it. So after server respond us to some response, yeah. So browser should handle this response, yeah, and next give some arguments or something like that to our code, yeah. Next, it's directly internal browser compute. So it's directly duration of handled response in our function, in some callbacks and so on, and directly rendering of HTML. Yeah. So if you add all of these items, you can have all time of rendering. So from time to when you press the button to time when you can see some result on the page. So unfortunately, there are no frameworks or libraries which can help us to measure this value. Because we made some deep investigation, I made a lot of prototypes with a lot of trivial and non-trivial libraries, and unfortunately there are no cool and cool stuff for doing this. Today we are not going to speak about internal server computing because there are a lot of cool stuff for measuring server computing, such like AppDynamics, I don't know, maybe New Relic, and I don't remember exactly, but there are a lot of cool things. Yeah, time of response and internal browser computing. But maybe we will talk a little bit about time of response because our instrument can measure latency, a little bit latency. Making decision took about 5, maybe 6 months. During this period it was created very deep, very huge document with analysis of actually existing solutions. Yeah. So a few words about our application. Yeah. So because I usually say huge single page application, big single page application. So we are currently using Groovy on Grails on the server side. It doesn't matter for my presentation. And also we use Backbone on the front-end side with some additional add-ons, maybe libraries, and so on and so on. As I remember, about 250,000 lines of custom code without any libraries. So it's very, very huge single page application. We are currently working in healthcare. So decision about end user experience monitoring can be divided into the 3 main questions. Yeah? First question, actually, what do we want to collect and how can we collect the data? Because you need to know, actually, you have to decide something. What do you want to collect? Yeah? Which events, which time, which measure, which actually you have to decide it. Yeah? And during this process, it was a lot of questions. Which framework do we use? How often should we measure? Yeah? What size of info? How? What else? What data do we need? And so on and so on. So you can see a lot of questions with answers. Yeah. Second part of end user monitoring, actually something in the middle of this. Yeah, it can be how can we store the data. Yeah. So after we measure something, we have to save this data somewhere. And during this period, also we asked a lot of questions. Which service should we use? How are we going to scale our servers? Yeah. Which size of logs should we save? And so on and so on. So actually, right here, you can also see a lot of questions. And third, when we store the data, we have to somehow analyze this data and maybe draw some charts, maybe render some reports, maybe do something. Some helpful and maybe useful stuff which can help us to analyze our data. And also a lot of which chart should we use, which framework, which approach should we use, and so on and so on. And after that, we start to think. Actually, three approaches. First of all, what and how do we want to collect? I was investigating a lot of frameworks, and you can see right here most part of them. So it was AlertFox. Actually, sometimes it was hard to get trial version of this framework because actually we don't want to buy your approach before we try it. Yeah, maybe it's not so good. Maybe it doesn't meet our requirements and so on and so on. So it was AlertFox. Yeah, it was a Boomerang, very simple JavaScript approach. It was New Relic. Yeah, it was Bucky client. It was Catchpoint. Guys from Catchpoint actually very strange because even now they are writing me letters, and I can't stop it. I don't know what should I do. Actually, unfortunately, I don't know what should I do. Okay, it was Kojak. Kojak very huge library for measuring performance, but part of performance is go to exactly Kojak. So part of our functionality and part of Kojak. So we can't use this library for measuring our performance of rendering. Also, it was Google Analytics. Google Analytics can almost all things which we want, except a few extra things which we want. I'm going to talk a little bit about this in 1 minute. Google Analytics, also it was web page tests. Also, I was doing some investigation in Google Chrome plugin because we want to access to RAM memory. We want to get access to CPU, yeah, and we want to collect and manage Google Chrome crashes, yeah, because not so many presentations and not so many guys exactly today and in common says about this, because memory leaks in JavaScript is very bad thing, yeah. And if you are going to create single page application, it's good. You can use React, you can use a lot of cool instruments for this, but if you leave your application, for example, 1 day or maybe 2 days without any reloads, so even maybe React, even Angular, even some framework can crash your browser, because we have only 750 megabytes per one page, as I right remember. So for this reason, it would be cool. It was one of our requirements. It would be cool to measure these crashes and get from these crashes something like dump of memory. Yeah. So how many memory do we use in this moment? How many CPU do we use in this moment? And maybe some other stuff from JavaScript which we can get. It was custom Chrome plugin. Yeah. It was phantomas. Something in the middle. Actually, it's good thing. And also it was Caliper. Yeah, it's library for measuring performance. It was created some prioritized list, yeah, with main requirements. So here you can see not all requirements, but big part of them. It was front-end technology. It was license, measuring of latency, measuring of custom events, measuring of time of rendering, measuring of UI routing, CPU access, actually RAM access, extra installation, and so on and so on. So you can see a lot of requirements, yeah, which we have to cover. Yeah, it would be cool if we cover this. Each of these requirements has priority, yeah. And actually about Chrome plugin, it was very cool approach, but extra installation, yeah. So it's needed to write some instruction. So hello user, you should go to Google Chrome store, for example, and install our plugin because you want blah, 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 and you have to access this, and this is extra installation, so this is not so good for us. And after a lot of decision, a lot of brainstorming, and so on, we have decided to use CaliperJS. So CaliperJS is a library. It's a very cool library, but unfortunately, we found that guys who written this library, unfortunately, don't want to support. Maybe they can support. I don't know, but. We got this library, we add some small changes to this library and push it to GitHub, to our public repository. So if you want, you can find it, and you can modify it if you want, and whatever you want. Actually, all changes which we added to this library was structure of data which it said, because we need some special structure, yeah, some JSON with special fields, and so on and so on. So it was only one changes which we made to this library. Okay, let's go ahead. Second part is sync solution. So we need to save this data somehow, and sync solution can be divided also into 3 main components. It can be Splunk. Does someone know what is Splunk? Yeah, cool. Okay, I'm going to talk about Splunk after maybe 2 slides. It can be Splunk, it can be application server, our application server, yeah, and also it can be something like separated analytic controller, because analytic data is very huge chunks of data, and we are going to send it very often. So it can be something like DDoS, maybe, I don't know, a lot of requests to our server. So we need to decide approach of storing the data, yeah. And the main thing which we uses for choosing this approach was actually simple architecture quality attributes, yeah. It was such quality attributes like complexity, it was fault tolerance, it was scalability, availability, usability, maintainability, and performance. You can see each of them was prioritized also, and we have assessed all of these approaches with abstract points. Yeah, it was from, as I remember, from 1. It can be 1, 2, 3. Yeah, and we have assessed these 3 approaches with abstract points. Sorry, and we got such results. So Splunk is good, but it has some disadvantages, small disadvantages. Yeah, So you can see application server is the best for now, but let's see for separated analytic controller, unfortunately more disadvantages than Splunk and even than application server. Actually, separated analytic controller might be Node.js server, which can handle a lot of simultaneously requests, and it would be very helpful, but support of Node.js, because currently we are using Groovy on Rails, and it's Java developers, Groovy developers, something in the middle. But for Node.js, we need to hire new guys. Second, scalability of Node.js server, we need to create some new approach for scalability, yeah, and it will be other servers, and so on and so on. So the best solution in this case will be application server. So we have decided to use it. We created in our application server some special controller, which is responsible for storing the data, and actually that's all for synchronization approach. And the last one, analyzing data. The key point was complexity. We don't want to add new complexity in our application, because you know a lot of cool stuff we can see every day. Some guys create some new libraries, some guys create new frameworks, some guys create new language, and so on and so on. We also can use it, we also can implement it, but sometimes support of these libraries or support of these languages can be hard. So the key point was trying to not add new complexity in our application. And it was AppDynamics. Yeah, AppDynamics is a very cool approach. Actually, our guys is currently used for backend and partially for MS SQL servers. Yeah, also it was usually Splunk, the great instrument for storing, analyzing, and manipulation of data. It's very easy, extremely easy for configuring, and it can be third-party plugin or maybe third-party solution. Yeah, but after some analyzing, after some decision, after all of this stuff, we have decided to use Splunk. Yeah, because it's very easy to customization, and actually we have the license on the Splunk. Yeah, so yeah, it was our approach. Let's talk a little bit about Splunk. So actually, our approach all was created among Splunk. Yeah, because this is very great and very cool instrument. You can install it for free, and actually you can use it maybe forever for free, but there is some maybe restrictions, some rules. So you can't handle more than 500 megabytes of files per 1 day. Actually, for maybe startups, for maybe some I don't know, sandbox or something like that, it's more than enough. But if you want to go to some production and so on, for example, now in our application we use more than 2, maybe 3 gigabytes logs, some different logs from database, from application server, our analytic logs from Redis, for example, and so on, so on. So all of this log we get together, yeah, and send to Splunk. And Splunk automatically analyzes data, and actually Splunk has very cool UI when we can search, when we can get some alerts, when we can create, I don't know, some alerts, search, and dashboards, reports, and so on, so on. Actually, this is very cool instrument. I was very impressed about it. Also, Splunk can allow us to create some custom dashboards. It's very cool. So you can see this dashboard. It's about 1, 2, 3, 4, 5, about 6 monitors, maybe 7 monitors. So it was hard to create such snapshot. It was first time for me. So we have created according to our data, according to our metrics. Yeah. So we decided to use some metrics in our application, which we want to see in charts and which we want to follow, which we want to analyze. And I'm going to talk a little bit about actually our Splunk dashboard. So let's go. First of all, okay, it's something what I want. First of all, yeah, you can see in the bottom So right here you can choose environment which you want to monitor. It can be, for example, it can be QA. For example, in our example, it can be QA, it can be beta, and it can be live. For now, we are using this approach in QA and beta, and maybe on this week, maybe next week, we are going to move this approach to production. So there are a lot of testings and so on and so on. So you can see, you can switch here environment which you are currently monitoring. Next, you can see count of logs which we have analyzed because we need to know this information. Because, for example, if we made some decision according to 2 rows, maybe 5 rows, it can be incorrect. So for this reason, we have implemented this count. First of all, yeah, so you can see this pie chart. This pie chart shows us the slowest classes in our application. This is Backbone, and we use class name. Yeah, we use class name which we add in constructor. Yeah, and you can see that render of such strange class is very, very slow. So this is a winner. This is a potentially class which we have to improve, or maybe which we have to actually at least see, maybe pay attention on it. Yeah. Second table is almost duration of rendering classes. Second table is almost the same, but in the table. Yeah, it's aggregated data. We have implemented such value like wait. Yeah, wait. It's count of calls. I don't remember how to translate mathematical operation. Plus, minus, multiply. Thank you. Sorry. Count of calls multiplied to average of rendering. Yeah. So we can see that we shouldn't see to some class which is used, for example, twice, maybe 3 times, maybe 4 times. But let's see. We have, for example, some class which is called 5,000 times or 5 million times. Yeah, so we pay attention on this class. Okay, so, third and fourth, this is charts which can help us to see actually latency. Yeah, so this is a time of AJAX requests. So if we take, for example, data from AppDynamics, and if we take this data, so we can get this data from AppDynamics, and it was value about internal server computing, and we can get this value, and internal server computing will be something like that, and this will be latency, real latency, which we can measure actually. Yeah, and fourth table is show us almost the same, but also with weight and with aggregation information. Sorry. Okay, let's go ahead. Fifth table is show us the trend of some classes. Yeah. So for example, if we decide to, okay, guys, let's improve this class because it's very, very slow. But what if it was special cases which is, I don't know, which cannot be repeatable and something like that. So you can see the trend of rendering of this class. It was almost the same. Hop. Something was wrong, and the same. So we can probably try to find this special case, or maybe this special user, or maybe this special, I don't know what it was, but the trend of this class is the same. So I think is everything okay. It doesn't matter about this. For example, it's last 30 days. Okay, let's go ahead. Trend line of chosen class. 6 is average navigation time. Actually, we divided our approach, our tables, to two main areas. First is navigation time, so router from one row to second row, and second area is about event inside some module. Yeah, so you press some button, something changes, something doing, and hop, and green flash message in the bottom of the window, and so everything okay. So we want to measure all of this stuff from time when you press the button to time when you see this dialog. Yeah. And for this reason, average navigation time, so it's from rendering, it's from routing. Yeah, when you press to one button, you will be redirecting on the UI to the second module. Yeah, it's average. Actually, it's average navigation times from one module to second module, and you can see some picture, real picture. So it's not only in JavaScript. You press button and you see picture, and this time you can see here it's average, it's maximum. Yeah, this is the worst cases. So you can see sometimes it can be 30 seconds, 50 seconds. It's very strange situation, but we are currently working on improving of these strange situations. Aids table can show us aggregated data. It's about first and second graphic, but charts, sorry, but with some additional things. Yeah, navigation and user experience. And ninth is using for troubleshooting, because I have implemented something like search. So our JSONs looks like here. So unfortunately, it's not so good picture, but it looks like this. And second, event navigation time, that in the module, not for rendering, or I mean not for routing. It's inside some module. So it's also average. It's also maximum time, and also aggregation table. And for troubleshooting, we have implemented raw data. Okay, this is very cool thing. Yeah, so you can see in real time your application. You can know about how fast users can see your page, and so on and so on. But this is only I don't know, maybe half of the problem, because there are several. Actually, this is last slide. There are some additional issues, maybe questions, which you have to know and which you have to investigate. First of all, monitoring strategy. Yeah. So now we have turned it on only for 1% of our users. Oh, okay, no problem. Only for 1% of our users. It was created mathematically by I don't know how to exactly translate, by house. I don't know house. Yeah. So we can know how often, for example, if we try to get random value, how often, for example, we can get 5, maybe 4, maybe 1, and blah 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 blah. So we have implemented only for 1% of user. Yeah, user with the same session ID will be still observed. What does it mean? For example, if you load your application, and if you reload, for example, page again for some reason, I don't know, for some reason you reload your page, and you will be still observed because you have the same session ID. And your monitoring will be turned off after your session ID will be expired. So it's very cool approach and very easy. And also turn on for manually for specific user. For example, let's imagine some situation when some user call to our customer service and say that, wow, something wrong, I can't use your crappy application, and it's very slow. Okay, let's take me your user ID, and we will try to understand what does it mean. And with socket ID, with sockets, we send this user ID, and we try to monitor what does it mean. And it depends on tier. So now we monitor only on QA and only on beta. Okay, continuous performance improvement. It's very cool to first of all observe, to see some results. Second, to analyze, and the last one, not only to improve, but trying to save the same level, at least the same level of performance. We don't want to decrease performance. We want to increase at least, and at least, for example, not to decrease. So for this reason, we are going to write some test with using Node.js, for example, with some time assertions, and actually that's all. So define process of troubleshooting. It's also very hard because we need to figure out what exactly do we want to monitor, how often do we want to getting this data, and so on. Second, start to fix slow classes. And define acceptance criteria for fixed issue. It's also very hard to understand because you can't go easy to QC and say, hey, let's test my bug. Okay, what should I do? Where is acceptance criteria? How can I know that my user story or my bug was fixed? It's very hard, exactly for these cases. And the last one, define process of performance monitoring and tracking. It have to be automatically because now it's manually using and we want to define this automatically. And actually that's all. And I don't have enough time. Question if you have.